Good afternoon, ladies and gentlemen. I hope you all enjoyed lunch, and welcome back to the afternoon session of the Data Science Festival Main Stage 2022. It's my pleasure to be able to introduce Ryan Jones and Tara Tahseen from CFC Cyber Insurance Underwriters. Ryan's one of the directors, and his interest is in getting the very best data to brokers and underwriters for cyber insurance decision making. He's got 10 years in the cybersecurity industry, responding to incidents and building forensic teams for investigations. Tara is one of the graduate scientists at CFC, using data science and machine learning for optimizing and understanding underwriting performance, quoting journeys, and data enrichment. So over to Ryan.
Thank you very much. Oh, and a round of applause as well. Oh, this is good. I thought I'd only get that at the end. So, an introduction to innovation in an industry that stands still. So hopefully you don't think that insurance completely stands still because you have turned up here, so that's a good sign. But I think in some ways it's warranted, that reputation that we stand still. We do love to have a bit of paper in the insurance industry, and some of that's our doing, but I think a lot of that is to do with the regulation as well around insurance, because the last thing you want to do is have your house burned down. You phone up your insurer and they say, sorry, we all staked that on Luna last week, so perhaps we won't be able to pay your claim. You want it a bit more solid than that, ready for you to be able to rely on. I want to give you a bit of an introduction to CFC, because very few people know what CFC do, and the reason for that is exactly what we do and why you might not see that as a customer. So we're an insurer, but we're a type of insurer called an underwriter, and underwriters ultimately make the decisions about what they want to insure and how much they want to charge for it. We do this for SME companies, so small and medium businesses. So unless you run a small and medium business, you probably haven't heard of CFC. And the other factor is our biggest insurance policy is cyber. So cyber insurance, when people have a data breach, for instance, or they have systems downtime because of a hack, it's that kind of insurance that you can call upon, claim upon, to help you respond to that kind of incident. The other side of the coin is broking, and that is where a broker will have a relationship with someone who wants to buy insurance, and they will help advise them find the appropriate insurance and go to multiple underwriters like CFC and ask for quotes, and then they'll talk to their clients and advise them on the right piece. And that difference between underwriting, where CFC are, where we're making those decisions about the premium and whether we want to write the insurance, and the brokers, which is sort of our sales flow, is really important for this presentation. A little before we get into anything more, a little bit about me and what I do at CFC. So I run a team called the Insight team, and that is a large internet scale data collection capability for the organization. So it can do things like scrape websites, gather data from lots of different APIs, and do that within a handful of seconds so that we can make these decisions very quickly. And that data then goes to our data science team, and that's when Tara comes in. Do you want to introduce yourself, Tara?
Hi, everyone. So I'm a graduate data scientist at CFC. I joined CFC about a year ago now. Before that, I was a student at the University of Cambridge, so I was studying physics for my bachelor's and master's. And my main interests at CFC include how we can use data in order to accelerate our quote journeys, as well as optimizing underwriting performance.
So for this presentation, I'm going to give you some high level to show you how this all fits together, and then Tara's going to talk the tech. Okay, so let's start and think about where an insurance policy comes from. Let's go back and compare how things were about 100 years ago to how things were now. And let's use a really, really famous example of something that had insurance. Let's use the Titanic. We all know how this story ends. So when a broker was trying to get insurance for the company that owned the Titanic, what they did is they spoke with their customer, with that company, and they put together a pack with all of the details that the underwriters would need to know about the Titanic. So what is it made out of? How big is it? How many people can go on the boat? How many lifeboats are there? That kind of information. And they took it to a place called Lloyd's of London, which is a building, a marketplace in London, where there's lots of different underwriters that physically sit in the same place. And they took it around and they asked, okay, based on all of this information, would you like to provide insurance? And this is the actual piece of paper where the underwriters, and you'll like this bit, wrote their names under, where the names come from, to say, yes, I would like to insure the Titanic. Of course, it all went wrong for the Titanic, but Lloyd's paid out. They had their insurance claim paid. So that's how things looked just over 100 years ago. What do things look like for small business insurance now in 2022? Well, a broker speaks to a client. The client then puts lots of data into a form, and this is so tragic, but this is one that came to us this year, where the client faxed their broker their form, thanks very much, and then the broker decided to attach this to an email and send it to multiple underwriters, like CFC. So, okay, well, we're using fax machines. That's progress from 1912, I guess, and even email. But we've not come that far in some ways. It's not that different. Brokers shopping the insurance risk around into different underwriters to see if they'd be willing to write insurance. Now, that seems a bit nuts. Surely it's not just in email. Surely that's not the only way people are buying insurance for businesses now, and it's not true. We can accept insurance through email, we can do mobile and web applications, and we can also do API. However, what we'd love to do is just bin everything and have an API. Unfortunately, this is the reason why we can't do that. Over 80% of our inquiries come from email, which sounds nuts. We're technical literates in this room, and we think that is absolutely crazy. Who wants to do business over email? But I'll tell you why. The brokers are acting rationally. There is an absolute killer app for email, and I'll show you what that is. The BCC field. The wonder of the BCC field means a broker can get one form filled in, lazily just whack 10 underwriters in the BCC field, kick it off, throw it out there and go, and get a handful of quotes back. That's very different to having to take the data and type it into 10 different websites or web apps or apps on your phone. And it's very different from having to have the technological capability to integrate with a whole bunch of APIs and bring it back. So they are acting rationally. And it made me think of a prayer I learned when I was younger, which is this one. Grant me the serenity to accept the things I cannot change, the courage to change the things I can, and the wisdom to know the difference. This is what we're doing at CFC. We understand that it is going to be a long time before brokers want to do all their business via API. It's going to take time. We have to accept that. But it doesn't mean that we can't do a whole world of innovation behind that. There's so much opportunity there. We need to know the difference. It's powerful to know the difference. I know that might sound a little bit like we're not trying hard enough. We're not trying to innovate enough. But I'd like to give you a completely different example. Go back to 2008. The founder of Uber found themselves not being able to get a taxi on a business trip and thought, wouldn't it be great if I had a button on my phone, I could press it, and taxis would turn up? And that turned into a fantastic business, right? Cities all over the world. What if that same person was in 1988, for instance, and sitting there not being able to get their taxi and thought, you know what, wouldn't it be great if I invented smartphones? If I then got them in every single person's pocket across the globe, and then I could build a great taxi app? That would be nuts. That's not the way to innovate in the taxi industry in 1988. So I think it's really powerful to have these boundaries in what you should, what's really valuable to innovate in, and what really you should leave alone and accept that that's the way it's done, and let's innovate where we can. So this is where I'm going to hand over to Tara, because Tara is going to take us through accepting the fact that we're going to get a hell of a lot of emails with some crazy attachments. How do we go about passing those proposal forms and starting an automated journey on our side, even if it's very much not automated on the broker's side?
Thanks, Ryan. Okay, so I'm going to take you through the first step in our journey to automating quotes. So in order to write an insurance policy, there are certain bits of information that we need. So first of all, we need some data from the clients. So this includes the name and address, the client website, the revenue, and the headcount. So we also need some details about the type of insurance policy that they would like to take out. So this includes the limit, so that's the maximum amount of money for which they are covered, and the excess. So that's the money they are liable to pay should they make a claim. And as Ryan said before, there are three main mediums in which brokers use in order to get in contact with us with inquiries. And brokers typically use email, so that's 80% of the time. So as data scientists, we want to turn the data contained within inquiries into structured data in a database. So how do we go about doing this? Well, let's first think about inquiries via mobile or web and API. So these mediums require responses to be very specific, so we can impose what data types we want the responses to be, as well as the character length of responses. And brokers have to answer the exact questions that we want. So this means that it's very easy for us to get the data in the format we want, because it's already in that format. If we think about emails, however, email permits a large degree of freedom, whereby you can write whatever you want in the email text, and you can attach any kind of attachment as the application form. So this means it's a lot more difficult for us to extract exactly the data that we want. So the first step in this pipeline is to have some sort of text recognition stage to turn the data contained within attachments into unstructured text data. From this, we need some sort of custom logic in order to extract the exact data fields we want from the unstructured text data. So if we take a moment to think about data accuracy, the pipeline on the left will produce data accuracy of about 100% because of the specificity imposed by these mediums. On the right-hand side, however, we have data accuracy which is much less than 100%. And this is because when we're searching for the information we want, we have to sift through a lot of information that we don't want, that is added as in supplement. So as said before, email is the primary medium that brokers use, and so we're going to spend a lot of time working on this pipeline instead of forcing brokers to adapt and use mobile or web applications and API. So at first glance, it may not look like such a challenging journey. So we only have two steps, text recognition, and then extracting the fields that we want. But let me show you why it's actually much more complicated than just that. So on the left-hand side of the screen, you can see CFC's insurance application form. So it contains all the questions we want to know the answers to. And if we receive this application form 100% of the time, this would make our life super easy because we know exactly where the responses are located. Unfortunately, this isn't the case. We only receive our own application form about 10% of the time. So the rest of the time, we receive applications from a multitude of other insurers. So this includes application forms such as this one on the right. So you can see that the format of the application forms is vastly different. There are also a lot more questions asked which we don't ask, and some questions which we ask that they don't ask. The ways in which the questions are phrased also differs to ours. So you can see there's a lot of variability between the application forms. And this is just one example. There are many, many more that we receive. So you can start to see the kinds of challenges that we have to face when building logic to ingest and parse application forms. We have to create a model which is agnostic to the form in which we receive. So this shows you why other insurers make our lives difficult. But let's take a look at how people also make our lives difficult. So with an application form that you can write the answer into, you have complete freedom over what you can write. And this person has really exercised that freedom. So this is a response to a question asking how many employees does your company have. So you can see that the client has put two completely different responses. One is handwritten, one is typed. And I believe the correct answer is 770, though it'd be quite difficult for an algorithm to pick this out. So this is something we have to account for when building our logic. Here's another example of a difficulty. So this is where someone has inputted their revenue incorrectly. So we have one too many zeros, making this 44 million instead of 4.4 million. We also have difficulty with ambiguity in handwriting. So here, this could either read 250,000 or 250M, depending on who's reading it. Checkboxes can also present us with a challenge, especially when they're formatted like this, whereby the unknown is not next to the box in which it is corresponding to. And we also have variation in the ways that currencies are represented. So these are all many challenges which we face in solving this problem. But there are a few tools out there which we can use to help us along this journey. So let me just show you an example of one. So here you can see an email from a broker which is asking for cyber cover for a client's Manhattan pizzeria. So this is just a made-up example to illustrate. So I've passed this through Microsoft Language Studio, which is part of Microsoft's cognitive services. So this is a natural language processing model. And as you can see, the model has extracted the key entity types within the text. So it's labeled things which it thinks are organizations and people, and also quantities and currencies. So this is something which can really help us when we're trying to decipher, when we're trying to look at what data we want to extract from the form. So, for example, if we're looking for revenue, instead of searching through all of the text from the form, we can just search through entities which have been labeled as currency. So using machine learning web services like this really helps us to accelerate our journey to a productionized solution. So that example illustrates how we can use readily available web services in order to address generic questions and generic problems such as text recognition. We ourselves don't have to reinvent the wheel. We can capitalize on these great services which are readily available. What this means is that we can spend our time focusing on the task at hand. So that is extracting the data we want from the unstructured text data. So this is the domain-specific problem. So our business expertise is most suitably focused on this part of the task. So I'm just going to go through some of our lines of thinking when we're trying to construct logic to do this. So here again, you can see CFC's own application form. And when we're building logic to interpret the information on this form, we loosely replicate how a human would read and interpret a form. So we would think about things such as the proximity of the response to the question. We would think about the position of the response compared to the question. So in English, we read left to right. So this means that the response is usually to the right of the question or below. If I bring up the application form from the other insurer that I showed you before, we can see that we have to think about synonyms and different ways to pose the same question. We also need to be able to process data contained within checkboxes, because here you can see this insurer has chosen to contain a lot of their data in checkbox form. So that's just given you a brief insight into the large degree of variability that we have in this problem. But I just want to introduce you into this proverb. So don't let perfect be the enemy of good. So we could spend a lot of time trying to create a perfect algorithm which can handle any kind of form that it sees and extract the data perfectly. But in reality, this just isn't feasible. So perfection distracts us from our main aim, which is to get something productionized. So it's much better to productionize an algorithm which is a bit rough around the edges, but iteratively improve it with live feedback, rather than design something, spend months and months working on something which is perfect, but only perfect for our reference data sets. Okay, so that's just a quick overview into this bit of work that we're doing around reading proposal forms. So I'm just going to hand you back to Ryan, and he'll tell you a bit more about the information that we need to make a quote.
Thank you. So thinking about what you need to provide and what an underwriter needs in order to make a decision on whether they want to provide insurance and how much is appropriate to charge for it. Let's think about those things. And why not let's use the example of home insurance to think about it. So the first thing is what to insure. So that is as simple as the address. That's enough, just that one thing to identify what is it that we're insuring. Great stuff. The next thing is claims history. Are you someone that claims once a year on your policy, high propensity to claim, or are you a kind of person that would only claim it in the very worst situations, so have very infrequent claims? The next is cover levels. So we need to make sure that if you have a house worth £300,000 and it burns down, you have £300,000 worth of cover. If you find out you've got £50,000 at that point, it's a bad day. Even worse than it was because your house burned down. So that's cover levels. And then there is risk questions. So there's all the other questions that we can think of about when you get your home insurance policy. So it could be, how many bedrooms do you have? Do you have smoke alarms? Do you have a British standard lock on your front door? Do you have pets? All of this information is then talking about the risk and helping us learn more about the risk. So there's 4 things there, but when you think about the volume of the questions, and particularly the challenges you have in answering those questions, it looks more like this. What to insure? An address. Did you claim in the last 3 years? No. Cover levels. Yes, my house is worth £300,000, please. That's great. That's really quick. Everything else is in this risk question bucket, and it takes you a hell of a lot of time to do, and no one likes filling out those massive long forms. We want to automate the filling out of those risk questions. That's what we're trying to do at CFC, and it has massive benefits across the board, regardless of how you choose to do business with us. So, if you choose to do business with us via sending us a proposal form via email, for instance, it means there may be questions that don't get asked on the proposal form you've given us, but that are really important to us. If we can create and enrich that data ourselves, it means that we don't have to go back to the broker and say, oh, can we ask some more questions, please? Because the broker may already have 4 or 5 completed quotes ready for them and think, well, actually, it's just I've got 5 already. It's not worth me wasting my time trying to get a 6th. You don't get any business, CFC. That's not what we want. If you think about the website option, then it means we can ask less questions. We can keep it really simple. It makes it nicer to use a website. And if you think about API, if you've got the option of, hey, integrate with one API, all we need is those 3 pieces of data and you're done, versus, oh, if you use this different API, you'd have to add another 40 questions to your online form. It's very easy to see which one is easier. And from CFC's perspective, the more quotes we can get out there, the more picky we can be about who we want to underwrite, which means we can get the best risks, we can get the things that we want to insure, but still get to the level of premium that we need to get out there, because that's the balancing act that every insurer has. Insure enough that you can make a decent business out of it, but don't insure rubbish. The other great thing about generating the answer to these risk questions yourself is you can do it in a consistent way. So Tara spoke about the synonyms you need to look at, but it's not a like-for-like synonym oftentimes. So there might be someone saying, what's your revenue versus what's your turnover? Pretty close. But someone else may say, what's your revenue in your last completed year's accounts? or what's next year's revenue projected to be? All of these are going to elicit slightly different answers, whereas if you have a consistent approach where you're automatically generating this information, you know you're treating all of those customers fairly and you're getting the answer to exactly the same question. Tara's going to take you through how we're looking at one of these challenges, one of these many, many risk questions, and determining how to get that answer.
Okay, so there are lots of big questions that we're trying to address using data, but probably the biggest of them all is answering, what does a company do? So this may seem like quite a simple question, right? But let me show you why it's actually much more complicated than it initially seems. So when people ask the question, what does a company do? A lot of people think about industry or business sector. So let's take an example. So think about Amazon. So Bloomberg categorizes Amazon into the retail and wholesale industry. But does this give an accurate picture of what services Amazon, all of the services that Amazon partakes in? So let's take a closer glance into these more granular activities. So we have e-commerce, we have cloud computing via Amazon Web Services, we have digital streaming via Prime Video, artificial intelligence, manufacturing, and there are many, many more. So we can see that the question, what does a company do, encapsulates a lot more than just the industry classification. So you can really attack this question from two different directions. So coming from the left, you can give an industry classification or business sector classification. So this is a high-level overview whereby you pick just one industry. Or coming from the other direction, you can ask, does this company partake in this specific activity? So for example, does Amazon partake in artificial intelligence? So there are different use cases which require these two different answers to this question. So for example, thinking about pricing of cyber insurance, it may only matter to us the industry of the client. So we may only care that the client is either operating in technology or operating in mining. But let's take a deeper dive into the use cases for looking at the more granular activities. So different activities have different levels of risk. And as an insurer, we have the freedom to decide what risks we are happy to take on and what risks we are not. So here's an example of a risky activity. In the past few years, there have been many cases of breaches of healthcare data. So healthcare data is really sensitive information. So think about if your medical services or medical treatments were exposed to the public. This could harm many, many people. But what's worse than just one hospital's data being breached? Think about hundreds of hospitals having their data breached at the same time. So this can happen because of targeted cyber attacks at medical billings companies. So just for some context, medical billings companies partake in itemizing medical services provided to a patient and sending a bill for these services. So they're relevant for private healthcare. So these medical billings companies effectively act as sinks for the data from many, many hospitals across a region. So they contain data of hundreds of thousands or perhaps millions of people. So as an insurer, this sends massive red flags to us. So medical billing is a risky activity which we don't want to insure because of the potential of a very harmful data breach. But how do we know if a company is taking part in one of these risky activities? Because we don't ask them for specific details of everything that they do. So we have to find this out ourselves using data. So I'm sure many of you have tried to Google your name at some point, and you've probably found that there have been thousands of results. You've probably seen that there's a lot of information on there that perhaps you didn't know was there on the internet. So here on the screen, you can see that I've Googled CFC underwriting, and you can see that there are about 97,000 results. So companies also have a lot of their data online. So This internet footprint contains a lot of useful data which we as data scientists can play with and try and find out more about a company's services. But it's not just as simple as drinking all of the results that we find through a search engine. It's much more nuanced than that, and let me show you why. So here's the first result that comes up on Google for CFC underwriting. So it's our company website. Company websites contain lots of useful data about a company and the services it provides, but we have to remember what the main purpose of a company website is: marketing. So a company may portray itself in a more favorable light, and it may omit certain things such as pitfalls or certain risky activities or behaviors which it may partake in. So we have to look to other sources too. So we can think about looking at business directories such as Companies House. So these are official sources, so we can trust the data, but we may have problems of data being out of date. We can also look at social media pages such as LinkedIn, and also third-party sources such as magazines and blogs. So you can see that there are a lot of sources that we can look at. But the important thing is being able to critically evaluate where data is coming from and how we can trust the different sources. But once we've got this data, how can we use it to address the question, what does a company do? So at CFC, we build machine learning models to do this for us. So looking back at our example of Amazon, we want a model that if we put all of the data we can find about Amazon, if we put that into the model, we can output a classification, so retail and wholesale. But we also want models that if we ask them, does Amazon partake in artificial intelligence, they will say, yes, it does. So we also want to be able to flag up these more granular activities. But I said earlier about not needing to reinvent the wheel when addressing generic tasks. So is that what we're doing here? Do we really need to make our own models? Well, the answer is yes, and we have a very good reason. So at CFC, we have our own bespoke industry taxonomy, and this acts as the target classes for machine learning models. And the reason why we have this is because our motivation for classifying business industry is risk-driven. So this is subtly different to the motivation that other taxonomies use. So this is best illustrated through an example. Take an architect. So when LinkedIn classifies an architect into an industry, the important thing is that the architect is working with buildings, so houses, offices, etc. And this leads to the classification of operating within the real estate industry. At CFC, the important thing when we think about architects is that they are liaising with clients to provide a service. So they're effectively acting as a consultant. So this means we classify them into the professional services. So you can see that the subtle difference in the motivation of classifying clients into industries completely changes the classification, and this is why we need our own taxonomy. Another thing about our taxonomy is that it is constantly updating to reflect the emergence of new industries. So if we think about SIC codes, so Standard Industrial Classification, this is one of the most widely used taxonomies across the world, but it was last updated in 2007, so that's 15 years ago. So there have been many industries which have emerged since then. Think about cryptocurrency, think about space tourism, perhaps in the next few years. Our taxonomy reflects all of these, and this is why we need to build our own taxonomy and build our own machine learning models. So that's just a brief insight into how we are using data and machine learning to address one of the big questions at CFC. And with that, I'm going to hand you back to Ryan.
Thank you, Tara. So we've taken you through just one of those examples of the kind of challenges that we're trying to solve at CFC. And there's many, many more. Think of all the different questions we need to ask, whether they be firmographic in nature, what does your company do, what's your revenue, where are all your offices, for instance, or it could be something specific to a product. So an example of that would be, if we're looking at cyber, then it could be measuring specific parts of an internet footprint, how many systems does an organization have, how secure are those systems for that company. And these are really, really key things that we need help on. That's why we're here, because we're looking for your brains and we want you to flex them at CFC. So we're at the stand in the corner later, and we'd really love to talk to you about any of those roles. But the last thing for me to say is I hope that this has shown how, even though we're in an industry that doesn't move that fast, it does not stop the innovation. It does not stop the application of data, and that we really need to push things forward at CFC. I'd really love to take any questions that you have. Thank you.
So we've got about 5 minutes for questions. So anybody like to start at the back?
It's been a while since I've worked with character data and brought it all back. How terrible it is. It's quite interesting to hear. But do you have like an internal process where, you mentioned that your process is kind of data 100% accurate. So you must presumably have cases where your final generated quote is like either way too high or way too low. So do you have sort of an internal process to control for that? Or is that something you just sort of have to put up with?
Oh, okay. So the question was, how do we control for when, if we quote too high or quote too low through automated processes? How do we control for that? So we're in the process of automating it, but currently everything is like stamped by a human to make sure that the price is correct before going out. So we don't have any mistakes with that going to the client.
For us, it's an iterative process. We need to get there, as Tara said, it was about sort of get something out there into prod, check your answers, and that's really where we are. And then over time, it's about, well, let's the 5% that we're most confident in, let's let that through, and then let's make that 10% and 20% and 30%. And our 5-year target is 80%. So that we're only having people looking at that to decouple the growth of the company from the growth of the number of underwriters that we have.
So you mentioned that in whole the industry is relatively slow to innovation. What has caused CFC to require that step to have that innovation? Because sometimes innovation doesn't really happen unless there's a genuine identified need. So what need did CFC identify to use that to start that innovation journey?
Yeah. Okay. So the question was, if the insurance industry isn't innovating that much, why are CFC doing, and what's driving that innovation? So I would say it is ambition that is driving that. We cannot achieve the growth that we want to achieve without this innovation. And one of the key factors is how we want to address a part of the market in a cost-efficient way that others can't. So if you think about providing cyber insurance for large organizations, for instance, then you're going to have a large premium. That means you can have people sit in front of look at proposal forms, have an interview, talk through, and then make a decision. If you're saying, we're going to unlock a part of the market, it's not cost-effective to provide insurance to small businesses unless you can do this kind of analysis at scale, and unless you can be really efficient in the way that you deal with quotes and make decisions, and make good decisions as well. And that's really the driving process. The board has said, in order to do this, we want that market. In order to do that market, we have to have this tech in place. So let's do it so we can be there. Do you want to go with that, or shall I go with that? Oh, okay. Yeah. So the question was, small and medium businesses. There's not that much information out there about small and medium businesses. How do you sort of address that? I mean, you are 100% correct. That is our biggest challenge, right? Big businesses, floated businesses, public businesses, let's go look at their annual returns. Let's go look, and that's what they reported their revenue at, for instance. Great. But the challenge is the opportunity. So yes, it's difficult, but we want to tackle that. So examples of that are the way that we're building models from information that is publicly accessible. But a big problem is not all of the information is always there for all of the companies that we're looking at. So, for example, we could look at the amount of traffic that a website gets, for instance. We know that bigger companies have more traffic in general. We can look at how many employees that an organization is likely to have. We could look at what industry they're likely to be in. And combining these data sets gives us an opportunity to give a prediction. But then we have to see, okay, we're good at providing a prediction for this industry in this region, but not good at providing an indication for that industry in that region. And that's where now let's do our 5%, now let's do our 10%. It gives us an opportunity to get something into production that we're confident in, but only for a slice, and then slowly, iteratively work on increasing that slice. And the answer is, it's really difficult, but that's why it gives us a competitive edge, because if it was easy, everyone would be doing it. Thanks. Do you want to go with that, or shall I go with that?
I could go.
Yeah.
So the question is, what kind of algorithms do we use with our data to make predictions? So we're currently exploring many different avenues. So for the business activity classification, we've been exploring different kinds of neural network, but also more explainable kind of algorithms. So naive Bayes was an example of one. But we're really exploring a wide range of how we can use machine learning in different ways.
I think what's really interesting is that with the insurance industry, you are staking significant amounts of money on your models. So it's not just about, my model went wrong and the click-through rate reduced, so we'll roll back. It's, we've insured a whole bunch of companies that we shouldn't, and whatever claims we get, we're stuck with. So there's interesting back and forth between deep and shallow learning, where deep learning often allows us to find the features that are really interesting, but building a shallow learning model from those features then gives us the explainable outcome that then we can explain to our backers and say, this is why we're staking so much. So I think that sort of relationship is really interesting. And I think we're up for time.
You're quite right. Indeed, we need to get on to the next speakers. But let's thank Tara and Ryan again.